Yeah, I think you are comfortable with Linux and HDFS commands, yes? I feel.
Yeah.
Yes, yes.
Okay. So today I'm going to revise the, I think, MapReduce program we are going to discuss today. Okay. I think we have not done MapReduce program, yes? Word count program. Let me open the program. Okay. So now we are going to we are looking into the Java program. It is a MapReduce program. Okay. So first of all, we need to know the data types in Java. So how many of you know Java data types among you three people? Like we have a int, float, okay, long, and string. Different types of data types are there in Java. So how many of you are aware of those data types?
I'm aware of those data types. I have 9 years of experience in Java.
Oh, okay, it's nice. So here, these are all the about two, the about two are no Java libraries. Okay, import java.io.io exception and some other Java utilities, and the remaining are Hadoop related libraries. Okay, that means so this is a library, and we are going to add some other external jars while configuring this program. Okay, import org.apache.hadoop.fs.bath. This library is useful to pass the input and output directories from outside of the program. That means when you are going to run a jar, you need to provide input and output. So if you don't use this library and this here in the driver class, we need to write some properties, like you can say, this is my driver class. Here I have a one class. These two are file input format dot set input path and set output path. So these two will not allow us to write the code. Okay, so that is why we are using org.hadoop.fs.path. Okay, this is a library, another library to submit a job through the JVM client. That means configuration, config library. So if you won't use this, we cannot. It will not allow us to submit the job to the from the JVM client to the job tracker. And this one is input and output. Okay, you will get some Hadoop IO exceptions. We have a different types of exceptions in even Hadoop like Java. Okay, and this is for map reduce, like map function and reduce function, how it is going to be functioning. That means without, if you don't use this mapped function, mapped library, it will not allow us to write mapper class and reducer class, even map function and reduce function. Okay, and these are all some other utilities, that common utilities that we are going to use in our Hadoop. Okay, and this is a main class, and we are going to write mapper class. Okay, here you can use whatever the name you want here. Okay, public class, I'm using some map word or something. Okay, map word. it is extending MapReduce base and implements mapper class. How many of you know interface and interface concepts in Java? I think Prabhakar, you already know. I think you are expert in that. So what
Yeah, I
about
definitely
Ankur
know.
and Sandeep?
I guess
definitely. I'm the
Ankur
one
is
that's
expert.
experienced.
I'm not. Yeah, yeah. Even I know
Uh,
those. Yeah.
Okay, see, that means this is it is going to be implementing, and extending is nothing but we already these are predefined classes. Okay, uh, this these are the class, these are predefined classes from this library. Okay, these are the predefined classes from this library. So we are going to extending the MapReduce base class and mapper class. Okay, this is we are going to declaring some variable one. Okay, one, and we are assigning some one. That means it is a constant. This is not going to be changed already. We have already assigned some one. Okay, so usually it is a MapReduce data types. Okay, iteratable is a MapReduce data type. Even text is also a MapReduce data types. Whereas in Java, text is string. In Java, we are going to call it as a string, but whereas in MapReduce, we are going to call it text. Okay, and the same thing we are going to call int in Java, whereas in MapReduce, we are going to call int writable. Okay, again, these are all some classes in the MapReduce, but we are going to extend the MapReduce base and mapper classes. So we can use all these classes. Okay, iteratable and the text. Okay, and what is also a variable. What is also in a variable. That means here we are we are counting some watts based on the space. Okay. So I will suppose, for example, I'm going to give one file for you guys. The simple example, very basic example. It is Monday, some Tuesday, Wednesday, some Thursday. Okay, again some Sunday, some Tuesday, some Wednesday, again Thursday, Friday. Okay, and you can go some Friday and Sunday, on Monday, and again Tuesday, for example. Okay. So now this is my file. Now I want to find out the word count. This is a one word. This is one word, and this is also another word. Okay, this is also another word. So I need to find out how many times each word is repeated. So Monday is how many times it is repeated in this particular file, and Tuesday how many times, Wednesday how many times, Thursday how many times it is repeated. Okay. Now, so that is what, suppose the word here, the variable is belongs to, variable is nothing but it is going to be changing each and every time when we are putting that variable into a loop. So that is why I am declaring it as a word variable. So every time word is going to be replaced with Monday, Tuesday, Wednesday. No, in such a way it is going to be replaced. Whereas I am going to declare one. One is also a one variable, but I assign some value one. Are you clear here? Yeah, Prabhakar and Sandeep.
Yes. Yeah.
Yeah, you will get the use of one and word in the below classes. Okay, you need to wait for 1 minute. So this is my map class actually. Okay, this is my map class. So how it is going to be uh, reading the file. Okay, so here if you see MapReduce is based on some key value pair. Okay, MapReduce is based on some key value pair. Now you need to find out what is key and what is the value. What is the key and what is the value. Now I think I already explained you the procedure, but again I am going to here map how it is going to be now. Here my name node is there, just for no example.
It's
Here
like
my
trace key
data
value
node.
pair or a JSON values key value pair.
Yeah, it is. See, I will tell you what is a key and value pair. It is based on the value we are going to compute value. Compute is nothing but some operation. That is whatever it may be. It is some aggregation operation or some average, okay, or even multiplying. So we have a different aggregation functions. So the aggregation we are going to do in reduce function. We can say in the reducer class, whereas mapping we are going to do in the mapper class. Here I have a job tracker, first of all, just here, and the task tracker is this. This is also a task tracker. And I think I already explained you the same concept yesterday, I remember. Okay, here my blocks will be there, as you know. Just for example, think that. Okay, these are all my blocks. The data is in blocks basically. So my file is split into different data nodes. Okay. Here and here and here it is there, my file. So think that you have in one block I have some first line. What is my first line? Monday, Tuesday, Wednesday, Thursday. Monday. Just I'll copy the first line. And it is in the second block. The second one is the second block. Okay, here I have it. Now what I'm going to do is I have written some program. Okay, this is my program. Okay, now so initially the input is a text file. Okay, my text file name is something called some file1. This file is called some file1.txt, or you can say some input.txt. I am going to pass some input. This is called input.txt. Here, as soon as my file is already in HDFS. Okay, now I am not loading any data. It is already in HDFS. So I think I already told you, when if you want to store the data in HDFS, you don't want any map reduce program. HDFS client will be taken care to write the data. To write the data into data nodes, HDFS client will be taken care. Okay, HDFS client will be, it is in either inside the Hadoop cluster or outside the Hadoop cluster. It may be. Okay, usually it is in Hadoop cluster itself. Okay, that means it will be in name node. So you are going to do the operation through the name node host mission. From there, the name node will be taking care of everything. Okay, writing the data into data nodes. Okay, everything. And here you need to observe one more thing. The data is going to be writing sequentially. Okay, for example, here I have my HDFS client. So the data is going to be first. It will my HDFS client has to contact the name node what are the available slots. Okay, what are the available data nodes to store the data. The name node contains entire information of all the data nodes. So which data node is free, which data node is how much space is left. So is it possible to load the data which I am passing. For example, my file size is some 200 MB. Okay, 200 MB. So how many each block is some 64. Each block is 64. 60. So how many blocks it is going to be taken care? My file size is some 200. Okay, this file size is 200 MB. So each block is some 64. So how many blocks it is going to be taking? 200 by 64. 192. So it is almost 3 blocks it is going to be occupied. So this is my 3 blocks data. So once the HDFS client will send a message to the name node will give you the available slots to store the data again to the HDFS client. So HDFS client will go directly there and it will store the first line here, that 64 MB. Again that will send in another second line is going to be stored in some other data node, and again it is going to be sending to here, and it has to give the acknowledgement to this thing. Okay, it is stored. Okay, it is done. And this name node has this data node block has to also give to the acknowledgement to this block. Again, this block has to give the confirmation to the HDFS client, and HDFS client has to give reply to the it is stored in this particular this. Okay, this is how the flow is going to be happen. You understood how it is going to be writing the data into HDFS data nodes? Are you clear on this?
Yes, I think.
Okay. Now here this is my name node. So name node contains entire information, and here it is my job tracker. And I have another JVM client. So the JVM client and HDFS client, it will be in the same mission or maybe in different mission. That is depends upon the bandwidth of the project or client or account, whatever. Like it depends upon their bandwidth, how much money they have it, they are going to put it. Okay, so you can even this name node, this JVM client and HDFS client, everything they can put into the name node mission itself. It is up to their wish how they want to install it, how they want to establish the nodes. Now here it is my JVM client. JVM client. So this JVM client, what it is going to do is, it is going to submit a job to find out the how many times the word count is repeated. Okay, for the file input.txt for this file. Okay, so name node knows okay the input.txt where it is. So usually our job is going to be submitted to the job tracker. Job tracker will send in a request to the name node, please give me the directories where the input.txt is stored. So the name node will give you the information about in which data node and which directory, everything it is going to be giving. And again the response will come to the job tracker. So as I told, on each data node they are going to install some task tracker. Okay, task tracker. Oh, T is missed, sorry. Task tracker. task tracker. Okay, this is also a task tracker. Okay, so now my job tracker is going to be assigning the job to the my task tracker, all the task trackers, because okay, it knows where it is. Okay, the job tracker already got the information from the name node, where is the data. Okay, so the task tracker is going to directly hit on the data blocks. Okay, it is going to be hit on the directly data blocks. Okay, and here they are going to frame a one input split. This is one input split. Okay, this is also an input split, and this is also one input split. So from the block, the data is going to be passing to the input split initially. Okay, initially. Okay, and from here we have a one record reader class. So that means that this line is in this input split. This line is in this input split. Okay, this line is also in this input split. This line is also in this input split, and this line is also in this input split. Now here our program, what it will do is string line equal to value dot toString. So this line is, what it is doing is, it is going to read the data from the input split, okay, line by line. Okay, it is going to be reading line by line. So this is going to be reading, and then in the map task it says this string is going to be divided into some tokens. Okay, tokenizer is some array. Okay, and it is always some variable. So in this variable, the line is going to be splitted into different words. Okay, that means I have a words is nothing but here. This is a one word. This is a one word. This is, so it is going to be splitted into a like one element. You can say as you can say some element or some word. Usually array is array, how it is going to be store the element, the values in the form of some elements. Element 1, element 2, element 3, like that. Okay, it will start with 0, 1, 2, 3, like that. So here, from here, the record reader class is going to be reading, and it is going to be assigning 1 1 for each word. Okay, for each element it is going to be assigning some 1 1. If you see it here, once it is reading and it is splitting into some word, and it is going to put into some tokenizer, and here my loop is while tokenizer dot has more token. So obviously my tokenizer had more tokens. Yes, Monday is one token, Tuesday is one token, Wednesday is also one token, Thursday is also one token. So my loop is while tokenizer dot has more tokens. If it is a more tokens, it is going to be setting like word dot set. Word is a variable. I think I already told you, yes. Okay, word dot set. Word is nothing but it is going to be replacing every time. Okay, Monday dot set. It is going to be setting 1. Okay, tokenizer dot next. Okay, so it is going to be setting like this. Dot set. So Monday, Tuesday, like that. And in the output it is going to be giving output dot collect word comma 1. 1 is already, we know 1. It is already defined here. So that means it is not going to be changing. And word is going to be changing for each and every time. Monday, Tuesday, okay, Thursday, again Monday, Tuesday. In such a way it is going to be mapping. Okay, here it is forming like, okay, in the map task it is going to be forming in such a way Monday, comma.
What if the same word Monday repeated twice? Then how it will take?
No, first it will split it. It won't care about. It is taken from the first input split and it is divided. It is going to be merging after the map. Thursday, comma 1, Thursday, comma 1. So this is a first map. Okay, this is a first mapper. What it is doing, so it will keep it sometime, and again here also it is forming the same thing, and here also the same thing is going to be repeated. This is called map. Up to here it is in a map. Okay, up to here it is in a map, and then once mapping is done, okay, and it has to go to the reduce. It has to go to the reducer class. In the reducer class, we have another thing. Here the logic is, this is a reduce logic. In between the map and reduce logic, we have another concept called sort and shuffle phase. Okay, shuffle and sort phase we have it. Shuffle and sort phase. Shuffle and sort phase is there. So we will get the data from this mapper and from also this mapper, because it is also splitted. This line is also splitted like the same. Okay, and here it is going to be framing such a way. First it has to shuffle it. Shuffle is nothing but it has to merge all of them. It has to merge all the mappers. So it is going to be framing in such a way like Monday, this is a shuffle phase list. It is going to be giving something like how many times Monday is repeated? 1, 1. Okay, 2 times it is repeated. Monday is repeated 2 times. And again Tuesday. And again Wednesday. How many times Tuesday is repeated 3 times. 1, 1, 1. And Wednesday, how many times it is repeated? 1, 1. 2 times it is repeated. For this, we don't need to write any logic. It is automatically doing. That is the beauty of Hadoop here. You don't need to do anything. Whereas in other technologies, in other traditional technologies, you need to write a logic for this also. But whereas in our Hadoop, in the MapReduce, you don't need to write any logic for this intermediate values. Okay, from the mapper output, from here everything is a intermediate. So why I am calling an intermediate is, once our program is running and everything is done, these values are not going to be stored anywhere. As soon as our program given output, these are all going to be erased. That is why I am calling those are all intermediate values. So again, I'm going to give Wednesday is done. So what I need to give? Oh, it went everything, man. Sorry. So how I need to do undo this one? Is there any command to undo? I think we don't have. Again, I need to write it. Okay, so in the shuffle, what is going to be done is Monday, comma, list of 1, comma, 1. Again, Tuesday, comma, list of 1, comma, 1. Again, after that Wednesday, comma, list of Tuesday 3, I guess here. Okay. Wednesday is 1, comma, 1. And Thursday will be list of Thursday how many times? 1, 2. Okay. Only 2 times. No, it is integrated with the data node. It is going to be integrated with the, because that is a daemon services. Both job tracker and task tracker are daemon services. So we no need to physically assign a submission to the task tracker. Okay, whatever, even input split is also a logical. Once the data is passing through that input split, it is going to be erased from the input split. So there is no data is going to be available. And that too, the input split when it is going to be created is as soon as the job tracker assigns to the job to the task tracker, the task tracker will create an input split. Okay, then only the data is passing to the input split. Until unless the job tracker is not assigning any task to the task tracker, it is not going to create any input split. Once the job is submitted, if the data is in some block, then only it is going to be create a one input split according to the block. Are you clear, Prabhakar?
Yeah, yes.
Thursday, and then again Monday, Tuesday, I have Wednesday, Thursday. I don't have Friday, Saturday also I don't have. Okay, I have only Sunday again. Okay, Sunday, comma, list of. So how many times it is repeated Sunday? Only 2 times, I guess. So for this, you don't need to write any logic. Okay, nothing you need to do. It is automatically going to be created everything. Okay, that too. This is an intermediate pair. This is not an end result. So end result is separate. Okay, now it is got shuffled. Now it should be in some short order. That means it is in some ascending order. So if you go for ascending order, which one will come first here? So which is the first value it is going to come here according to alphabetical order? It is Monday, Tuesday, Wednesday. I think Monday, correct. Then after that, first Monday it is going to be coming. Monday unlist. So Monday list 1, 1 only. It is going to be putting into some thought order. Then after that, Monday, Tuesday, Wednesday, Thursday, Sunday. After Monday, you will get MNOPQRS. Yes, you will get it. Okay. Sun, comma, list list 1, 1. Okay. After Sun, what is the next word? It will be to Thursday. THU, comma, list 1, 1. After Thursday, what is the value? Tuesday. Comma 1. After Tuesday, you are going to get Wednesday. Comma 1. Okay, this is the value you are going to get. Okay, so this output is passing to our reduce function. Okay, our reduce function, this output is going to be passing. So here I'm going to for reduce. Here, so I am going to declare one variable sum equal to 0. Sum equal to 0. See, and maybe you can confuse with all this word. This is a key and this is a value data type. This is a key data type and this is a value data type. Now if we come here what is the key? The word is a key. Yes, Monday, Tuesday, Wednesday, that is a key, and the values are list 1, 1. Here in the map phase, key comma value. In the sort and shuffle phase, you will get key comma list of values. In the reduce phase, you are going to key of sum of value. Okay, in the reduce you are going to get sum of value. So I am going to apply sum function here. Okay, sum function, sum logic, I am going to use it here. So initially I am going to assign sum equal to 0. Okay, now while values dot has next, values are nothing but Monday comma 1 comma 1 1 1 1 like in the array we have given as values, those are called values. So it is going to be reading next values as next. First it is going to be reading 1. Okay, here if you see the iterator operator, what is this meaning? This is a sum equal to sum plus equal to values dot next means it is a sum equal to sum plus value. This original meaning is usually in Java it is a sum equal to sum plus value. Okay, so each time when the loop is going to be performed, initially I have assigned a 0. Okay, initially I have assigned a 0 for this sum. 0 plus 1. So in the place of sum, what is going to be replaced? 1. Yes, you got this logic?
Yes.
So initially it is going to be assigned 0 for this because I already assigned 0. 0 plus value is 1. So I am going to assign some 1 here. So in place of sum it is going to be replaced 1. Here it is going to be replaced 1 when 1 value it is reading. First one. Okay, and then again here it is going to be replaced with 1 plus value is 1 again. So 1 plus 1, 2. So here it is going to be replaced with 2 until at the end of list it is going to be reading. So you can get the sum. So here what you will get? You will get, so it is going to be reading this one, the short output. Now here you can get something like Monday comma 2 and then Sunday comma 2 and then Thursday comma 2 again Tuesday comma 3 again Wednesday comma 2. So this is my reduce output. This is my reduce output. This is also a intermediate. Okay, from here up to here this is an intermediate. Okay, these are all intermediate values. So finally it is going to be reading, it is going to be writing into HDFS. Okay, consider only these values are intermediate. Now finally it is going to be stored into HDFS system, okay, with the tab separated. So something called Monday to Sunday space to Thursday to Tuesday 3, Wednesday 2. So in such a way it is going to be stored in HDFS, our Hadoop distributed file system. So finally you will get the sum equal to sum plus value everything, and it is going to be written the once entire list is done. Okay, it is going to be replace the particular key, some Monday some value, Tuesday some value, okay, Thursday some value, it is going to be replaced. Once the job is submitted through the driver class, okay, and it is going to be produce the output in HDFS. Okay, these are all the, okay, and this they are going to creating some instance object here to submit our job. You can get the job name also here. And this is ours is a text. Okay, by default the MapReduce program, if you won't specify any, either it is a text input or text what is the input format. Usually we are dealing with some text input format in our context. So that is why I have given. And here again data is going to be stored by default in text. By default it is going to be stored in text until unless you are not going to specify any format. If you are going to specify any format, that is going to be stored in that particular format, either Avro format or Parquet format. So that program is different, you need to modify something here. Okay, so in such a way it is going to be storing into HDFS. Okay, here again you need to main, okay, have to give map.class. Okay, what is your mapper class name, and you need to give the reducer class and combiner class. I will tell you the what is combiner after this program, once we executed this program. And what is our input format? Okay, ours is a text input format. So even for text input format also in the MapReduce we have some class text input format dot class. We already invoked some libraries on top. Okay, and it is going to be stored in a text output format. That is why we are going to invoke that library. And this is for, you need to pass input or output directories from when you are going to execute the program. Okay, that means in runtime. This is for submitting the job to our Hadoop, to the MapReduce. Okay, that means to the job tracker. So any issues or questions or concerns from you guys in this program?
I have no questions.
Yeah, Sandeep and Prabhakar.
I am little bit okay right now. So.
Okay. Yeah, Sandeep. Okay. No. So now I am going to execute this program. So how you are going to execute? So first what you need to, you need some input files. Okay, let me create a program. In the real time what they will do is, first according to the file they are going to write a Java MapReduce program. Based on the file they are going to write program. So I have some file file1.input.txt. Okay, that called some data. Now I know what is my file, so I'm going to write according to the file the program. The program is already written. Now I'm going to where you need to write the program. Go to your Eclipse. Okay, in the Cloudera, which I'm going to give. I already shared the VMware installation, everything, the image. So what you need to do is you can, okay, you are going to open your Eclipse. Okay, here right click, open. So you will get like this. Go to the file, new, go to the file, new, project. Okay, select Java, Java project. Next, give some project name. I'm going to give my project name is BATCH batch 1100. Finish it. Now you can click here. So you'll get some source directory. There you can right click, new. You are going to create some package. So the package name, I'm going to use some word pack, WORD PACK. That is up to you. Whatever the name you want, you can give. But it should not start with caps W. It should start with only small. Okay, it should not start with caps W. Caps W. That means whatever the alphabet you can give, it should not start with numericals, and it should not start with caps letter. Okay, word pack. Now my package is created. Now I am going to create a class. Okay, the class you are going to give, what is the class name, the main class name, not mapper class or reducer class. You need to give this one. Okay, word count. Copy and here paste it. You should know the class name, otherwise it will throw in an error. Now I created my class. Okay, this is my program. Now here I am going to write a program. Here now I am going to select this one. Copy and I am going to give paste here. So usually you will get errors. Why? Because this Eclipse contain only Java related packages. That means if you see it here, you won't get any errors here, because this is a Eclipse is mainly built for Java, and itself it has already, the libraries are already existed. All Java SDK related packages or libraries or everything is existed here. So that is why I'm not getting error. And what about these libraries? These are all Hadoop libraries. So I don't have any Hadoop functionality in the Eclipse. So I need to add some external jars. External jars are nothing but those are also some Java programs. Once they converted into a jar, that becomes an executable file. Now the jar contains some classes and packages. So in the jar, that is a Java program, there they have given in the external jars all MapReduce, that MapReduce based class, mapper class. Okay, all text input class, text output class, everything was defined and coded in the jars. That is why you can call it as a, those are default classes or super classes. So I am going to add those external jars to this program. So how you are going to add the external jars to this program. Right click on the here in the left hand side word count.java, go to build path and you can say configure build path. There you can go to the libraries and add external jars. So I have some jars. Okay, I am going to provide those jars to you. Okay, and you need to add this is this jar and this jar and this jar. These are the three jars if you want to execute a minimum basic map reduce program. And if you want to execute or you want to suppose you have created some other map reduce program that may be some XML parsing, so you need to add some other jars, compatible jars to that according to that program. It depends upon the program, but you need to add these jars even you are going to add for some other program, some other external jars. These are the basic jars, minimum jars, common jars we can say. So we need to add these jars to this program and give OK. Okay, and again OK. So I am not getting any errors, I am getting only warnings. Warnings is not a problem. Okay, now I have added and I am going to give Control S. I saved it. Now I cannot execute my Java program in Hadoop environment if it is a Java code. So I need to convert this Java code into a jar. Okay, as a jar program. Jar is a executable. Okay, so Java RK we can say Java executable program that I am going to execute in Hadoop environment. So for that, first you need to create a jar. How you are going to create a jar is right click on this, export and give Java as and jar file as a jar file. Next, and you are going to give, you are going to select the path for this where you want to store it. In your, it is my Eclipse is in my Linux system and that means in local system. So I am going to create it here and my current user is Cloudera. Now here I have my directory called batch 1100. This is my directory, so I am going to adding into this. Okay, okay. Now give next. Oh, back. So I need to provide some name for this jar. Okay, I should not give untitled. So I am going to give some word count or something, whatever you want, you can give it. I am going to give some word count. Okay, word count dot jar. You can give whatever the name. It should not be dependent upon any other class name or package name or project name. That is, it is an independent. Whatever the name you want, you can give it. Next, next, and finish it. Okay, it will show some because our program has some errors. That means some warnings. That is not a problem. Now I need to check whether it is there or not. So how can I check? Okay, give here. Clear this. So I'm going to give ls batch 1100. So I have a word counter. If it is in a red color, okay, so you are the only person having rights to execute this jar. So no other person has permissions to execute this program. As it is a my cluster, I am the only user for this cluster, so I can execute it. But if you go for real time, in the real time projects, so you are not only one person working on this project. So you have some multiple persons are doing the different work. So you are created the program, but your task is just to create a Java program and to create a jar. And the other person have got the task to execute this jar. So he don't have the access to execute this. So that is why you need to provide the permissions to this one. So if you want to provide full permissions, you can give like this: chmod 777. You need to specify where is your jar. Your jar is in, okay, BATCH 1100 slash word count dot jar. Okay. So now you will get in the green color. So that means everyone have the access in your project, okay, to access this program and even to execute this program. So how you are going to execute this program? So if you want to execute this program, you should have the input file in our HDFS. So now I will check Hadoop fs -ls batch 11. Yesterday we have created some files in our Hadoop directory with this name batch 1100. Oh, it is not there. Let me check. Maybe with some other name. Yeah, I think BATCH 11 PM. I guess my directory name. Ah, employee.txt is there. Now, I think 12 is deleted. Okay, it is not there. So let me find what are the directories available here. Yeah, I'm going to use some batch 13. Nothing is okay. I will take some other directory and I will create one file here. Okay. So as I don't have any permissions to create a file in directly HDFS through the command line, so I am going to create a file in my Linux system and then I will copy that file into HDFS system. So I am going to create one file batch 930 slash. I am going to give some input.txt. txt is not a mandatory. As I was habitualized that, I am going to give .txt. That is your wish. Either you want to give .txt or not. You want to give some other name, you can give it. Okay. Now I am going to just some Monday, Tuesday, Wednesday, Thursday, and Wednesday, Thursday, Friday, Saturday, again Sunday, Monday, Tuesday, Thursday. So I am giving like this. Again, if you want, you can give some Friday, again Thursday, again Tuesday, again Monday. So now I am done it. So once you did it, you need to give press escape, :WQ, this one. Now it is 10. Now if you want to check, you can give batch 930 slash input.txt. So this is my file. Now I am going to copy this file into my HDFS system. How I can copy? Hadoop fs -put batch 930 slash input.txt. Where I want to copy? I am going to copy into batch 11 PM. This is where I am going to copy. Now let me check whether it is there or not. Hadoop fs -ls batch 11 pm. Now it is there. Now I am going to execute my Java program by giving this is a input file. Now Hadoop, this is the, please remember it is very important, this command Hadoop space jar. What is my jar name and where it is? It is in local. Okay, if you are going to execute the jar program from the command line, that program should be in your local directory. Okay, Hadoop space jar and you need to give batch 1100. It is my jar. It is it in this directory. Word count dot jar, and what is your package name here? Your package name is wordpack. Okay, and your class name is word count. So I'm going to copy both. First I'm going to copy this one, word count, copy. My package name is wordpack wordpack dot. I'm going to give this one word count. Now I'm going to provide batch, this one, copy. I'm going to provide paste input file. I'm going to give again the output batch. Okay, where you want to it is in 11 p.m. You can give it 11 p.m. slash. I am going to provide you the output. So I am going to give some output directory called word underscore count, or you can give output out1. I am going to give. It is my first program. I am giving some out1, my directory name. So it should not be created before your program is going to be executed. So it will be created on the fly. Okay, in the runtime it is going to be created. Hey, the meeting is going to be it will be end in 5 minutes, is telling, unless the organizer is not joined. Hope so it will be up to 5 minutes. Okay, here. Now I will check whether my output came or not. Hadoop fs -ls batch 11 p.m. So out1 directory is created here. Now slash out1. Okay. Now I am going to view this. Copy. Hadoop fs -cat. I am going to give this one. So you got this output. Are you clear?
I think so.
Yeah, Ankur, are you clear?
Yeah, I'm clear.
Yeah, Prabhakar and Sandeep.
Yes, we are clear. Yeah.
Okay, we'll have the class tomorrow. I'm going to end up. We'll have the class by tomorrow the same time.
Okay.
Okay, you
Are
can.
we going to cover Spark in this Spark as well?
Spark introduction I am going to
Hello?
cover. See, Spark is it is again 25 hours class. So I am going to cover some introduction. Like what is
Okay.
Spark? Okay, or what is the main overall concept, and what is the differences between MapReduce and Spark. Okay, maybe some
Right.
2 or 3 some small examples.
Sure. Right. Thank you.
Okay. So, are you guys good?
I don't have any other questions, so I think I'm
Yeah.
good.
Yes.
Yeah, we are
Yes,
fine.
Ankur.